I work for EPA's Great Lakes National Program Office, and we have an open lake monitoring program that we've been running more or less for almost 30 years now. And I'm going to focus today, though, on our lower trophic level work that we're doing. And basically, the work informs a number of things. It helps us look at long-term trends and what's happening at the lower trophic level. It helps us document changes that are going on in the lower trophic level. But today, what I really want to do is just make sure that the fisheries folks, you folks, understand what we're doing, understand the data we're collecting. So maybe the information we're collecting may help you as you're trying to solve problems and look at what's going on with trends and changes in the fishery. And a lot of this lower trophic level information may feed into the work you're doing. So I just want to make sure everyone's aware of this work, and I'm hoping by the end of this, maybe something that we can develop more communication on, partnerships on, and coordination on. As Todd so eloquently read yesterday, here's our disclaimer. And so what I'm going to focus on in this talk, we do a lot of monitoring in our office, the Great Lakes National Program Office. We have the DO program, a coastal wetlands program, a sediment surveillance program, fish monitoring. But today I'm going to focus on the water quality monitoring program, which is our nutrient program, and our biology program, where we focus on phytoplankton, zooplankton, benthos, and chlorophyll. So we've basically been running this program with modifications since 1983. We currently use our research vessel, the Lake Guardian, and we sample twice a year. We sample spring during isothermal conditions, and we sample summer in stratified conditions. We've started sampling in 1983 in Lakes Michigan, Huron, and Erie. We added Lake Ontario in 1986, and we added Lake Superior in 1992. And I guess what's unique about our program is that we're really the only program that covers all 5 lakes on an annual basis. So we have pretty good spatial coverage, and our temporal coverage is only twice a year, but we do cover, since 1992, we have been covering all the lakes. So we have, now we have about 99 stations across the lakes. Most of our stations are offshore stations, our plankton stations, our water chemistry stations, our offshore stations. We have benthic stations, a number of benthic stations that are near shore in the 30 to 60 meter contour. But our plankton and water quality stations are in the offshore waters. So our nutrient program, we started in 1983 along with phytoplankton program. So we monitor total phosphorus, total dissolved phosphorus, silica, nitrate, chloride. We also started doing some metals recently. So we have a pretty good suite of nutrients that we've been monitoring regularly since 1983. And for the phytoplankton, we sampled Elypion, and in 1996, we also started sampling the deep chlorophyll layer. I'm not going to talk about the phytoplankton program in this presentation, there just wasn't enough time, but I'll certainly provide some nutrient trend information that we have. From a zooplankton standpoint, we started before 1997. We did some areas, we did some 20 meter tows, some 100 meter tows, but in 97 we pretty much started routinely doing 100 meter tows, the 153 micron mesh, and we also do the 20 meter tows. Today I'll focus, when I provide some of the results, on our 100 meter tows. Our benthic program started in 1997. We do ponographs. We have the benthic program. The benthos is sampled in the summer. We do some hexagenic sampling at a few stations in the spring. But the thrust of our benthos program is summer sampling. And we have, as I said, a total of 58 stations in our benthic program. Recently, we've added a remote sensing component to our program, focusing on chlorophyll A. Barry Lesh has been working with us, developing some algorithms to basically look at remote sensing and how it compares to our offshore stations. So he's been able to look at the satellite data and focus it in on the stations, on our sampling stations. So what I want to do is maybe just tell a little story on 4 parameters. And these are the 4 folks who were here yesterday. Todd Medeshine focused on these 4 parameters for Lake Huron. But what I'm going to do is add in these parameters for the other 4 lakes. So I'm going to focus on spring total phosphorus, which helps set the level of productivity for the year. Spring chlorophyll gives it a sense of bloom conditions. Zooplankton, obviously a food for the prey fish. And I'll also talk about dichorhea with prey fish food. So let's start with total phosphorus, and I'm going to run through this figure, and I'm going to keep adding a lake. So as you go from there, as you'll see, I have Lake Superior in yellow, and I'm just going to work my way down. Huron, Michigan, Ontario, and the 3 Eries. And so we basically have concentration and year. So Lake Superior, there was a blip in around 1995. And I'm not really sure what, if that was real or the story behind it. But otherwise, Lake Superior has been pretty constant since early 90s. I'm adding Lake Huron now. And Lake Huron's a little bit interesting, as most folks know. There was a period of decline in productivity in spring total phosphorus from the 90s to 2010. And what we've seen lately has there been some recovery in total phosphorus in Lake Huron? It appears that there's certainly been an uptick since 2010. I think I saw some fish data this morning. I think Owen Gorman showed that the fish biomass might be increasing over the last few years. So is there a connection there? It's certainly possible, but we'll have to see how this plays out over the next few years. Let's add in Lake Michigan now. And Lake Michigan, the decline is more of a linear decline than we're seeing in Huron. Is there a slight uptick in the last couple of years? Maybe, maybe not. I think we'll need a little more information and maybe a couple more years to get a sense of that. But again, definitely decline in Huron, decline in Michigan. Okay, let's change the scale and add Lake Ontario. And was a period of decline basically in total phosphorus in the 80s through the 90s. And there's been pretty much a leveling off of phosphorus since probably 2005. Let's change the scale again, and let's add in Lake Erie, Eastern Basin, Central Basin, Western Basin. Good luck with that. I'll go back to you guys working on Erie. I don't know how you interpret this. But anyway, the Erie's tough. I mean, everybody knows the Erie's tough, and it's variable, and things change much more rapidly in Erie. Just to summarize some of our spring total phosphorus results, we did find significant declines in Huron, Michigan, and Ontario earlier on. Huron declined since 2010, maybe an uptick. Declined since the 2000s, maybe an uptick since 2010. Michigan showing a continual decline. Ontario declined earlier in the 80s and has been stable in the 2000s. The 3 upper lakes are similar as far as phosphorus concentration, and really no overall trends that we can speak about in Erie and Superior. Okay, let's move on to chlorophyll. This chlorophyll data is from our satellite information, and it extrapolates across our open lake stations that we have for the various lakes. So again, we're going to work on Superior, and then I'm going to keep adding the other lakes, working down, Huron, Michigan, Ontario, and Erie. So Superior, a slight decline in chlorophyll, but 2014 and 15, there appears to be an uptick. Let's add Lake Huron now. And what's interesting is about 2002, 2003, Lake Huron chlorophyll concentrations came in below what we're finding in Lake Superior. Let's add Lake Michigan, kind of a similar thing. So the chlorophyll concentrations in Huron and Michigan are lower than we're seeing in Lake Superior. But also note that uptick in the last couple of years in Lake Huron and Michigan. is that real? Again, it'll take some more time to figure that out. But again, concentrations are really gotten quite low in Michigan and Huron over the last 10 years or so. Let's change the scale. Let's add Lake Ontario. Not much going on here. Let's change the scale again, and let's get into Lake Erie. And again, good luck with that. Overall, Todd showed this yesterday, but this I think is really cool. So now we have chlorophyll over the season, from March to October. This is Lake Huron, and you can see in the spring bloom, per the data, per the declining trend line that I showed, about 2004, the spring bloom in Lake Huron seems to have disappeared, and concentrations, chlorophyll day levels have really gone down. And now the highest chlorophyll concentrations in a seasonal basis are in the fall. So really a significant change in Lake Huron, very significant. Now I'm going to add in the Lake Huron with Georgian Bay and with the North Channel. And you can see that here, even though there was a decline for a while, in the last couple of years, it looks like productivity may have to come back if you include the bays. Most of this is because of adding Georgian Bay and North Channel. So chlorophyll A declines in spring blooms in Lake Huron, Michigan Superior, no overall trend in Lake Ontario. Lakes Huron and Michigan lower than Lake Superior over the last 10 years. And then we've seen an uptick, like we saw in total phosphorus in the last couple of years. In Lake Huron, most pronounced outside the main basin has been the uptick. Okay, let's move to zooplankton. I'm just going to give a very broad overview of what's going on with zooplankton. There's a lot of detail. If you want more detail, certainly, get a hold of Todd Nettersheimer or myself. But I'm going to focus on basically, this handful of species, the cladocerans. Daphnia is a great grazer, but it's also probably an amazing food source for the fish. A couple of species, the bosmina and the cyclopoid copepods, they increase when predation pressure increases because they're harder to catch, harder for fish to get a hold of. And the species that may show more evidence of oligotrophication are the dioptomid copepod, calanoids, and the limnocalanus. And those are to scale, by the way. Yeah. So I just have a few data slides on the zooplankton, but again, it's pretty cool. If you look at Lake Erie on the left, and this is biomass, zooplankton biomass on the bottom, and percent biomass on the top. And obviously you can see Lake Erie, lots of the red is the cladocerans, lots of cladocerans. And this is 2014, a snapshot of time, August of 2014. So this is not a trend analysis. This is August 2014, Ontario, we have the cyclopoids. And Michigan, Huron, and Superior, you can see, are very similar in 2014, both from a biomass standpoint and from a percent biomass. Mostly our calanoid copepods and limnocalanus are really the dominant summer biota for the zooplankton in Michigan, Huron, Superior, the upper lakes. Okay, so let's look at long-term trends from 1997 to 2014. Lake Erie, figure it out. Lake Ontario, things have declined a little bit, but we're still holding some cladocerans. There's a little bit of bifidobacterium that showed up in Lake Ontario. But Lake Michigan, Huron, and Superior again appears to be again the loss of the cladocerans. The cladocerans are in red in Lake Huron and Lake Michigan, except for maybe a blip in 2012. But cladocerans, particularly Daphnia, I guess that's really the Daphnia, has really disappeared in Huron and Michigan over the last few years. And again, what's come up is the calanoid copepods and limnocalanus. And just the convergence, I mean, you can just see the convergence from Michigan to Huron to to the zooplankton community in Lake Superior. Pretty striking. And relative biomass by group, maybe I'll see this a little better. I took off Lake Erie. We're still seeing some, this little line right there is the Bithotrephes, so we're still getting some Bithotrephes in Lake Ontario. Maybe this is a result of lower L-life, although I heard this morning the L-life biomass has not declined in Lake Ontario. It might be something else. But again, looking at Michigan, Huron, and Superior, just the reduction in daphnids and the movement towards the calanoid, limnocalanus community. So some of the key features about the zooplankton, again, the biomass declines in Huron and Michigan, the loss of the cladocerans shift to the calanoids, likely again due to decreased productivity, the decline in total phosphorus, decline in chlorophyll, so the zooplankton are following along and declining as a result. Lake Ontario is a little more complicated. It probably had a couple shifts. We saw an uptick in Bithotrephes in 2008, calanoids. It may not be so much an oligotrophication issue, maybe more vertebrate predation, but again, that's something that needs to be teased out. And again, showing Huron and Michigan and Ontario becoming more similar to Lake Superior. Okay, let's talk about diaphragma, the final piece of the puzzle here. And this is the 30 to 90 meter contour, and you can see Michigan has been gone since /05, Lake Huron shortly thereafter, Lake Ontario virtually gone. Superior, they're just loving this 30 to 90 meter zone, which I think Marty Hours called the Ring of Fire in Lake Superior. So Superior seems to be hanging on. Let's add on the deeper stations now, and certainly declines in Michigan, declines in Huron and Ontario. Well, Michigan and Huron, but it's still hanging on. Diaphragma is still hanging on at the deeper water stations, although at way lower abundances than it did back in the late 90s. Superior just, doing its thing. So Ontario, it basically disappeared from the less than 90 meter sites by 97, disappeared from greater than 90 meter sites by 10. Michigan and Huron disappeared from the shallow sites. Low levels but stable at the deeper water sites, and Lake Superior hasn't really shown the changes that we're seeing in the other lakes. So just to kind of sum everything up, and what I want to do is break this into three components from our time trend. So this is the again the things parameter I talked about: phosphorus, chlorophyll, diaphragma, and biomass. So this is the first line is going to be 98 to 2002. Okay, let's now add 2003 to 2007, where it looked like there was a definite change in what was going on in the lakes. So we add that, and we can see the phosphorus goes down, chlorophyll A goes down, diaphragma gets smashed, zooplankton gets smashed. In this 2003 to 2007 time frame. Now let's add on 2011 to 15, and you can see there might be a little bit of recovery, maybe in Huron on total phosphorus. Chlorophyll layers are still going down. Chlorophyll levels are still going down. Zooplankton have more or less leveled off in Michigan, Huron, and diaphragma seem to have leveled off as in the last couple of years. But again, these are the, we kind of broke this down into those 3, 8, 3-year categories where there might be things happening in the lake. So to summarize what we're doing in our office, so basically, we think we have kind of a unique program, and now we provide a consistent time series covering all 5 lakes over a 20 to 30-year time period. We can provide information on lower food web, productivity, availability of food for prey fish, impacts of predation. We can identify trends that can help inform decisions about management of fisheries. And the one thing I'll just throw out there is, again, we're available to provide information on any of this stuff that we collect to the fisheries folks. If there's anything that we collect that you think may help in what you're doing, in your fishery management work, feel free to get a hold of us, and we'd be happy to provide any of our lower food web data for the work you guys are doing and decisions you're making. So thank you very much for your time.